Okay, hello everyone. Next part we will introduce two key technology we used in the campus scenario. First is the network automation control, and another is the free mobility. And after these two technologies introduction, we will introduce the network design for the large and medium-sized virtualized campus network. So let's go to the first technology first. It's about the network automation control, and for our campus network scenario, we think much more about the network security, and as usual, we will think that the users come from the internet will be a security use client. However, nowadays more and more security problems is come from the internet. So that is very important to control the users communication in our campus network. So the first technology to control the users to access our campus network is just the NAC technology, just network automation control. So this slide is just introduce some basic or common authentication technologies we used in nowadays campus network. So after this course, I hope you can be able to describe the basic concept in NAC, just to know the basic architecture of the NAC. And the second is learn about typical authentication technologies, such as the 802.1x and the MAC address authentication, and also the portal. And the third is know the basic configuration of how to configure these three kinds of authentication technologies manually. However, in our campus solution, we suggest you can use the built-in authentication server just in the MSNC campus controller, and you can just deploy the authentication function on the controller, and it will just deliver these configurations to the specific devices. And for how the controller delivers the configuration, we will introduce tomorrow in tomorrow's experiment. So in this course, we will introduce how to manually configure these three kinds of access authentication. And final is know about the mechanism of the policy association. And for this technology, it's just in a simple word, it's just separate the authentication point as two parts. One is for the control, another is for the how to deliver the enforcement. And we will introduce it later. Okay. So first, let's see the overview of the NAC. For the background, we just introduced. Nowadays, more and more, we need to control the access for the users just in our internet network, because if an invalid user access to our campus network, it will bring a lot of security problem. And so we can use the NAC to do so, and the NAC is just the technology to allow only the authorized user and the security terminals can access our networks. And for the basic architecture of the NAC, it's separate to three parts. The first is for the terminals. The terminals is just like just the client or just the users who use any systems to access our networks, such as pad, the laptop, the PCs, the mobile phones, the IP phones, the printers, the cameras, and others. And another very important device is just the admission devices. The admission devices is an authentication control point. Also, we call it the authentication point. It's just the point or just the devices can receive the terminal's identification, and then it will send this identification to the admission server, just like the radio servers, and the admission servers also just the authentication servers. When it sends the identification to the server will verify the authentication. And if the user is a valid user, it will go through the successfully process and will send the authorization information to the admission devices, such as the ACL and VLAN and others, such as the UCL groups and some other authorization informations. So when the terminals want to access our network, it will based on the authorization information such as the ACL or VLANs to do the access control. So only the valid terminals can access our resources. So this is the basic architecture of the NAC. And this is the whole process for the NAC to do the authentication. It's just like I introduced. First, the user sends the identity authentication request to the admission devices. And as usual, the devices is switches, but also the AP, the routers can do as the admission devices. And then for the admission devices, it's just transmit the identity information to the admission server. And when the admission server receives the identity, it will verify whether the terminal is valid or not. And then if it is a valid terminal, it will send the authorization information for the admission devices. So, and then when the terminals want to access our network resources, it will receive the authorized ACL and VLANs, and then it will just based on the ACL to meet the specific resources that be controlled by the ACL. So for the policy-based control in the NAC, it's just like this. For different terminals, they will receive different authorizations informations. And then based on the ACL, it's just the rule to control the specific IP address to connect to different resources. So when it receives the ACL, it will match the specific ACL to the specific resources. And there are 3 resources domains for the terminals to access to. The first is the pre-authentication domain, and then is the isolation domain, and then is the post-authentication domain. And for the users access to the network, and all of them have the pre-authentication domain network permissions before authentication, including access to the admission server, to the DHCP server to get the IP address, or to the DNS server. And after terminals can successfully authenticate, the admission server will deliver the network access right to the admission devices to allow the users to access the resources in the post-authentication domain, just for the specific resources in our campus network. Just for the office users, they can connect to the office database, and for the maybe for the sales, they can connect to the marketing service database and others. And if someone has failed to do the authentication, they will come to the isolation domain to upgrade their various natural database, or to download the 802.1x client software. So this is for different terminals can get to different authentication domain to get different resources access rights. Okay, so for the overview of the network admission control, you need to know we separate the network admission control in three parts: for the terminals, for the admission devices, and for the admission authentic service. And then we will introduce some technologies. And for all of the technologies, you just use the NAC architecture to do the authentication. So first, the most common one is the 802.1x authentication. And this authentication technology is a port-based network access control technology. That means only we can configure this authentication on the admission devices interface. So when the admission devices receive the client's identifications information, it will just go through the process of the 802.1x authentication. And this technology uses the EAP over LAN protocol to exchange the authentication information, just to exchange the user's name, the password to the authentication servers, and the servers will go through the verify process. Okay, and for the networking mode, for the networking architecture of this kind of authentication, it just look like the NAC basic architecture. It also have three parts. The first is the 802.1x client, and for the client, it's just for the client need this kind of client need to install the specific client software, just 802.1x software. And then is the access devices. The access devices, just the admission devices. We can use as usual, we use the switches do so because we always use the access layers switches to we always configure this kind of authentication on the access layer switches. So as usual, the access device is just the access switches. And the third is just the authentication servers. Just you can use the normal radio server, or you can use the MSNC campus controller to do as the radio server who can support the authentication, authorization, and accounting servers for the users. And as usual, we will for just like me, for the always explore ins, we will always configure this kind of authentications because this authentication technology has the highest security. It can meet the highest security requirement. So this is the typical scenario for this kind of authentication. And there are two modes of the authentication. One name is the EAP relay, another is for the EAP termination. We have just mentioned that for the 802.1x authentication, it just uses the EAP over LAN protocols. So it will use this kind of package to contain the user's identification informations. And for the access devices, for the how the access devices to process the EAP over LAN packet, there are two kind of method for the access devices to do so. So for these two kind, we just separate the mode for two. One is the EAP relay. For the relay means the access devices. The access devices is just do as the relay devices. It do not solve the EAP over LAN packet anymore. It do not check you do not check the information contained in the packet. It just encapsulate this packet to a reduced packet and then send this EAP over radios packet to the authentication server directly. That means in this mode, it simplifies the processing on the access devices because it just directly sends this package. It encapsulates this package on the radios packet to the authentication server. However, for the servers, it must support two kind of protocols. One is the radios, and another is EAP. Because the up header is for the radios package, and the package contained the radios is for the EAP package, right? So for the authentication server, it needs to support both two kind of protocols. So for this mode, the server need to meet the high processing capability. And another is the EAP termination mode. That means the termination means the access devices is the end of the EAP overland package. So that means when the access devices receive this package, it will get the information from the this package, just get the identity of the clients, and then it will encapsulate this information to a normal radios packet, and then to the authentication server. So in this mode, advantages is that for most of the radio servers can support the PAP and check the authentication, and they can just recognize the radios package. However, for the access devices, it has a high requirement for these devices because it need to support the EAP protocols first to extract the basic information and then encapsulate it to the radios packet to the server. So there are two kinds of EAP, two kinds of authentication mode for this technology. And this is the whole process for the 802.1x authentication. And for each terminals, it has two modes to trigger the authentication process. One is triggered by the client. By the client, it means for the client, just for me, I just open the PC's client software and enters the username and password, so it will directly send the information to the access devices. So this means triggered by the client. And another is triggered by the access devices. When the terminals just send the AIP or DHCP package to the access devices, when the devices receive this kind of package, it will just redirect to client software for the terminals. Just open the client page to the users to enter the password and the username. So this mode is for the triggered by the access devices. And there are two kinds of access control, and mostly we will use the port-based access control. That means for the access devices, we configure the authentication here, and just for this specific interface, and for all of the for one of the users enter this interface go online, that all of the users who want to connect the network resources from this interface, they will get the same rights. And if one users go offline, that means all of the users will go offline, will not gain the access permissions. And another is the MAC address base. That means we use the MAC address to do the authentication. So the different users, they have different MAC addresses. So MAC address. So there's admission, there's authentication process are independent. So one user's access to the authentication process, it will go online. and when it go offline, it will do not impact any other users. So there's different from these two access control modes. Okay, next let's go through the full process for the authentication of the 802.1x. First, when user need to access the specific network, the user will start the 802.1x client, and it will enter the username and the password. So these informations will contain in the EAP overline start packet to the access devices to trigger the authentication process. So in this example, it's just use the first trigger mode, just the triggered by the client. And when the access devices receive this information, it will send back a request packet to the terminal. What's your username? And then it will contain the user's name to the response packet to the access devices. And this username is just entered by the users on the client, right? So when the access devices receive this identification information, it will just encapsulate the EAP response identity package into a radius packet, because we use a EAP relay mode as an example. So it will do not process this packet. It will just directly encapsulate this packet on a radius packet. So it will send this radius packet to the authentication server. And when the radius server receives this packet, it will search the username on its local database, and then it will check for a corresponding password and will generate a MD5 challenge ID, and then will send this challenge ID to the access devices, and then will send to the terminals. And when the terminals receive this challenge ID, it will use MD5 algorithm to calculate the password, and it will generate a cipher password, and it will send this to access devices and transmit to the authentication server. So when the authentication server receives the cipher password, just calculated by the MD5 algorithm, it will calculate it as well by the challenge ID, by the password it searched in its local database, and then it will match these two results. If these two results are matched, it will just accept this authentication. That means the authentication process is successfully. So it will just send the EAP success packet to the terminals. And after this process, the terminals has passed the authentication process, and then also the authentication server will send the authorization information to the access devices, such as the ACL, the VLAN, and when the terminals want to connect to the specific resources, it will send the traffic to the access devices, and then the access devices will do the traffic control based on the VLAN and the ACL. So this is the whole process for the first technology. And how to configure the authentication, and for the NAC, for the network automation control, there are two configurations mode. One is for the unified mode, and another is common mode. And in our course, we only introduce the unified mode because we just corresponding to our controller. Controller also can deploy the authentication configurations automatically. And if you want to deploy the authentication on the controller, it will deliver the configurations only use the unified mode. So for the manually configure of different authentications, we also just introduce the unified mode. And I think for the unified mode configuration is much simple because for different authentication technology, they use the same kind of process to do the configuration. So let's introduce the configuration. Okay, for the unified mode configuration of the authentication, they're separated for 3 steps. The first step is to create the different authentication technologies access profile. Just like this. And the second step is to configure the authentication. Authentication profile, and in the authentication profile, you will bind different access profile of different authentication technologies. And the third, that means just apply. You will apply the specific authentication profile on the specific interface, and then the specific interface is just for the access the admission device interface, and then you can just finish the configuration of the different authentication. So for 802.1x for the MAC address and for the port authentication, all of them use the same process to do the configuration. And so the first is for the access profile. If you want to configure this kind of authentication, you need to create the specific profile first, and then you can choose different authentication method. If you want to use the relay, if you want to use the relay mode, just for the access devices directly send the directly encapsulate the packet into the radius packet, you will change the parameters to the EAP. And if you want to use the EAP termination mode, you will change the authentication method to the CHAP or PAP. And you can also configure the type of packet that can trigger the 802.1x authentication. So this is triggered by this is the mode. As usual, we use the mode triggered by the client, just for the client enter the username and password directly by itself. And if you want to trigger by the access devices, you can use this command to configure which kind of package can trigger the authentication automatically. And in some scenario, you need to configure the layer 2 transparent transmission of this kind of authentication package, because for the EAP package is a kind of video package, so it will be isolated for the layer 2 switches. So for some scenario like this, this is the SW1, and this is SW2, and the SW1 is the layer 2, is a layer 2 switches, and for the SW2, we create the we configure the 802.1x authentication here, just in the SW2's interface. That means the EAP, so that means the SW2 is the access devices, right? So for the PC1, you need to send the EAP packet to the SW2, and then the SW2 will send this packet to the server. However, as usual for the layer 2 devices, it will just discard this kind of packet, because this kind of packet is a big deal packet. So if you if your network is just like this, just like this scenario, you need to enable the layer 2 transparent transmission of this packet just by configure this kind of command. So it's very important. Okay, this is the whole process for the 801x authentication, and we only for these three kind of authentication technology, we only introduce the access profile command first, and in the next slide we will introduce another two-step configuration command. Okay, and the second authentication is for the MAC address authentication. For the MAC address is used, this kind of authentication is used for the scenario of just like the dump terminals who cannot enter the username and password by itself, right? Because it cannot open the specific client to enter this specific account information, right? So for the MAC address authentication, is just you use the terminal's MAC address as the username and as the password to trigger the authentication process. So just like this, when the terminals send the ARP, DHCP, ND, or others package, the access devices will trigger the whole process for this kind of authentication. And for the access devices, it will just get the MAC address information from the package, and then it will contain these informations to the radius packet to the authentication servers. And for the servers, it will just check the MAC address, whether it have been plain and deployed on the service. If the MAC address match the valid MAC address, it will successfully go through the authentication process. So this is the whole process for the MAC address authentication. It's used for the scenario that do not require any client software, just like the dump terminals, such as the IP phone, the printers, the cameras. And also for the configuration, the first is to configure the specific access profile, and then it needs to change the authentication mode. One is for the chat, another is for the PAP. I think these two kind of authentication method, all of you are familiar with them, right? And the next is just to configure which packet can trigger the MAC address authentication process just by this command. And you can also configure the specific MAC address and the specific password. If you do not configure any password, it will just use the terminal's MAC address as the password to go through the authentication process. Okay, and the final common authentication method is the portal, and the portal is just the also like the web authentication. If just when you want to connect to Dublin, just it will you will search SSID, and you want to connect to a specific website, it will redirect to you a web page just to want you to enter the username and password, right? So this page is just the portal authentication page, and this kind of authentication is just named the portal authentication. So there are also two kinds of mode for this kind of authentication. One is proactive authentication. This means the user proactively access the portal authentication website through browsers, and that means the client is just directly connect to the authentication web page and enter the username, the password, and go through the portal authentication process. And another is redirect authentication. It's just like the scenario I introduced just now. That means when the client want to enter the maybe the talent.huawei and then it will redirect the authentication page first to the client. And after the client enters the username and password, and then pass through the authentication process successfully, and then it will finally get to the specific URL, just talent.huawei.com. So this mode is the redirect authentication. And for the portal authentication architecture is different from the MAC address and the 802.1x because it has 4 basic devices for the client, the access devices, and the authentication servers. And it has a special portal server. And for the portal server, it's just used to support the authentication web page to the client, just the function of the portal server. And this kind of authentication is normally used for the scenario that for the guest want to client to the enterprise network, it can just use the portal authentication, because when the guest want to use the mobile phone to connect to the network, it can redirect to the web page to enter the password and then to get to our enterprise network resources. Because this kind of authentication do not need any client software. So it's useful for the guest to enter the resources. And this is the whole process for the portal authentication. And for the authentication, it also has 2 modes. One is for the layer 2, another is layer 3. And the difference is with when the client and the access devices are in the same network segment, just a layer 2 network, we can just configure the layer 2 portal authentication. For this kind of authentication, we can use the MAC address with the IP address as identifier to identify different users. However, if the client and the access devices, they are in the different network segment, so we need to configure the layer 3 portal authentication. And in this kind of mode, it's flexible for the network, for the networking, but it's only can use the IP address to identify different users. And there are two kinds of protocols we need to use. One is for the portal access protocols. For these protocols, it's just used between the client and the portal servers, just to redirect to the authentication page, the authentication website. And we will use HTTP or HTTPS as the protocol. And another protocol is the portal authentication protocol. And this protocol is just used to send the to transmit the user's identification informations. And if we will transmit the identifier information between the portal server and access devices, we will use the portal protocol. And if we will just directly send this kind of information between the client and the access devices, we will use the HTTP and HTTPS protocols. So next page, we will introduce the different process for we use different protocols. And first, we will introduce the process for the client to get to the authentication website. First, before the authentication, the client needs to establish a pre-connection with the access devices. And this pre-connection is only for the layer 2 networking. And if for the layer 3 is no need for the client to establish the pre-connection. And then the client will send an HTTP request to establish the HTTP tunnel. And upon the access devices receive this request, it will redirect the client to get to send the messages to the portal server, because you need to enter the portal authentication to get to the website. So you need to communicate with the portal server first. So it will use a HTTP request packet to the client to redirect to the portal server. So and then for the client, it will send a HTTP connection request again to the portal server. And when the portal server receives the request packet, it will return the portal page. So when the client receives the portal page, just like this, it will enter the identification information just for the username, the password, and then it will transmit the identification information. So for the if you use the portal protocol as the authentication protocol, it will just use the portal server to transmit the identification information. First it will send the portal challenge request to the access devices. It will just reply for the challenge ID, and then it will send the portal authentication request information to the access devices, with just for the cipher the cipher users just by use the MD5 algorithm to calculate the change ID, the password, and then send the result to the access devices. And when the access devices receive this password, it will just exchange the identification information to the authentication. And this process, just like the 802.1x authentication process. And when the authentication server verifies the identifier of the users, it will successfully or failed of the authentication. So it will send back the result to the access devices, also send back to the portal server, also send back the result to the client. And when the portal server sends the result to the client, it will also acknowledge it to the access devices that I have sent the result to the client. So this is the process for if we use the portal protocol, and if we just transmit the identification information between the portal server to the access devices. Okay, and if the portal server do not support the portal protocol, that means it cannot transmit the identification information to the access devices. It will just tell the client to send the identification information directly to the access devices. And that means I need to use HTTP or HTTPS protocols to transmit the information. And there are two methods for the client. One is for the post. For the post, that means the request data is stored in the body of the HTTP packet. And another is user get. User get is just contain the username and the password just after the question mark of the URL, just like this, for the username and the password, and will send this information to the access devices, and it will go through the process of exchange the authentication information, authorization information, and account information to the authentication server, and then it will send back the authorization information to the access devices. So finally, the client will connect to our network resources. Okay, and the next part is for the authentication about the portal authentication. For the portal authentication is different from the first two, that it has a new devices that just the portal server. So first you need to configure the portal server. You need to enable the portal interconnection using the HTTP or HTTPS protocol. And then if you create a portal server template and enter the portal server template view to configure the different authentication protocol you used. You can use the HTTP, or you can use the portal authentication protocol. Just for the second process to remember, just for the how to transmit the identification with the access devices. For the client, and between the client and the access devices, you use HTTP, and between the portal server to the access devices, you use the portal protocol. And if you use the portal protocol, you need to configure the portal server specific information just through this way. For configure the server IP, the source IP, the URL, and others. And if you use the HTTP, you can just configure the URL is enough. Okay, after configure the portal server, you need to configure the portal access profile, right? Just like these two kind of authentication, create a specific portal access profile and configure the portal server template used by the portal access profile you just created in the front of this page. And you can change the portal mode as layer 2 or layer 3. Okay, and this is three kinds of authentications, and these three kinds of authentications, all of them are normally used in our real networks, and they just used in different scenarios. For the scenario who has the high requirement of the security, just like the office users, we will use the 802.1x authentication. And for the dump terminals who cannot use any client software to enter the username and password itself, we will use the MAC address as identification information. So we can, in this scenario, we can use the MAC address authentication. And for the guest, just the scenario with the sketched and moving user, just for the moving user, select the guest. We suggest you use the portal authentication. And in some scenario, one authentication technology cannot meet the requirement of the real network. So you can use the mixed authentication method. And the first mixed one is the MAC address bypass authentication. It's just like the scenario in the one access devices port. It connects two different terminals. One is for the IP phone, and then connect to a PC. So in this interface, for the IP phone, because it's a kind of dump terminal, so it will need to go through the MAC address authentication. However, for the PC, if we want to meet the high security requirement, we want it to go through the 802.1x authentication. So we need to use these two authentication methods together to authenticate the different users. So in this scenario, we can use the MAC address bypass authentication. So when this kind of terminals send the traffic to the access devices it will trigger the 802.1x authentication first, and if the traffic is sent from the IP phone, just like this, sent from the phone, it will trigger this kind of authentication. So it will send the response to the terminals to want the terminals to enter the username and password. However, for the IP phone, it cannot enter any information, right? So it will go through 3 times. When this kind of authentication is timeout, it will perform the MAC address authentication later. So for the IP phone, it will authenticate successfully by the MAC address authentication. And also, if the traffic is sent from the PC, it will trigger the 802.1 authentication first, and it will go through successfully of this kind of authentication. So in this specific scenario, we can use the MAC address bypass authentication for two kinds of terminals connect to one specific interface of one access device. And another mixed authentication is the MAC address prioritized portal authentication. For example, after passing the portal authentication, the terminals may disconnect from the wireless network when they move from one wireless signal coverage area to another, or when the wireless signal is unstable. And in this case, for the terminals, if it want to connect to the network, connect to the SSID to connect to the resources again, you need to enter the username and password again, right? So it's hard for the guys to do so. So in this specific scenario, we can use the MAC address we can use this kind of authentication. So it will send the HTTP traffic when the user is browsing a web page, and then it will perform the MAC address authentication first. However, for the guest, because the guest MAC address, the specific terminal's MAC address, do not be deployed on the servers in advance, so it will fail to go through the MAC address authentication. So this first process is failed, and then it will redirect to the user's HTTP request to the portal authentication page. So when the terminals get to the portal authentication page, it will enter the username and the password and go through the portal authentication process, and then it will successfully. And sometimes when the signal may be unstable, it will log out. The users can continue access our network resources by go through the MAC address authentication. So when it log out, the users will use the MAC address to go through the MAC address authentication process, because when it successfully passed the portal authentication, the MAC address has been recognized by the radio servers. So when it receives this MAC address packet again, it will just verify this kind of packet and will set it as a valid terminal. So it will go through the access to the specific resources again. So this is the scenario for the second mixed authentication method. Okay, till now we have just learned the three common authentication technologies. They are the 802.1x, the portal authentication, and the MAC address authentication. And then after you pass the authentication, you need for the users need to get the authorization, the specific authorization, and for the also for the users, if they want to log out of our network, for the servers, they need to recognize, because they need to do the accounting, right? You need to get the PIN of the network access. So next part is of the user's authorization and logout. First is the authorization. When the terminals successfully pass the authentication, they will get some specific authorization, such as the VLAN and ACL. And for the authentication devices, they will based on the different VLAN and different ACL to control the traffic access. And also, you can use the UCL group. A UCL group is just a group of users who have the same access rights. You can also, based on the user group, to configure the control policies based on the UCL groups. And so you can also authorize the specific UCL group to the specific traffics. So these three kinds is the basic common is the common authorization information is authorized to the terminals. And there are two special authorization templates. One is for the authentication free, just for the free rule. Before being authenticated, the user needs to obtain some basic rights, just such as to download the 802.1x client software or to upgrade the various database and others. So you can use the free rule template to do so. And also you can use the authentication event authorizations. Just means it meets different authentication events. It will authorize different informations, such as the pre-authentication or the authentication fields or the authentication server field. It will send different authorizations to the terminals, and you can authorize the VLAN, the UCL group, the service schemes. And for the user logout, it's also very important for the servers to know when the users log out of our network, because if you do not know the specific time, it will cause some incorrect accounting, and it may be cause some security problems, because the valid users have disconnected to our network, but for the servers it don't know. That means some attacker maybe just want to access our network, so it will bring some security problems. And there are three situations for the users to log out. One is the client logout actually just for the client, it can log out itself. And another is for the access and for the servers to force just to control the user to log out of our networks. And for these two parts, for the authorization and for the logout, we will do not introduce the detail about it. And for the authorization, we will introduce special authorization technology that is frameability in the next slide. Okay, the next part is for the whole configurations about the NAC. And for the user access authentication configuration process is just like this roadmap. The first is need to configure some specific access profile for different authentication. For the 802.1x, for the MAC address, for the portal, you need to configure different access profile. And then you need to bind this access profile to the authentication profile you have created. And in this authentication profile, you need to configure the specific authentication mode by binding the specific access profile. And then you need also to configure the user's authorization. And the authentication is need to corresponding to the specific domain, and the authentication domain has been determined by the 3A process, just like this. The 3A, you need to think about the authentication mode, the authorization scheme, the accounting scheme, and you also need to configure the radio server template, and create some local users. And the final, you need to apply the authentication profile in the specific interface for the switches. Also, if you want to, you can configure some extended functions of the authentication. So we have introduced the access process already, right, in the different authentication method introduction. And after that, we need to create the authentication profile. And in the authentication profile, you need to bind the specific access profile, just like this. That means you need to configure the different authentication methods. And then you need to, if you want to enable the mixed authentication method, you can just enable the specific authentication. This is the MAC address bypass authentication. And you need to configure the specific domain for the users to do the authentication. And there is the default one, and you can also configure a specific domain for the users and for different authentication methods. And the final, just to apply the NAC just in the different specific interface view, you need to bind the authentication profile you have created. Okay, next let's see an example for how to configure the authentication. And this is the scenario topology. And let's see the requirement. Further, access switches do not support the 802.1x authentication. That means if you want to configure this kind of authentication, you need to configure here. And if you configure here, that means you need to enable the transparent transmission for this kind of packet, right? So it's very important. And the enterprise network is small in scale and doesn't have any branches. The enterprise has no more than 1,000 employees, and a maximum of 2,000 terminals include guest terminals access the network every day. So for the guest, you need to we suggest that you use the portal authentication. And for the employees, you need to meet the high security requirements. We suggest you use the 802.1x authentication. And also for the dump terminals used in this scenario. So for this we suggest you use the MAC address authentication. And however, in this scenario, we only use these two kind of authentication as the example to introduce the configuration. So this is the data plane. This is the radio server's IP address and another server cluster's IP address, the network segment. And this is for the aggregation switch, just the switch tools VLAN. And for the access switches VLAN, and for the radio scheme for the authentication, for the accounting, and the password, and for the authentication domain. And the final is about the authorization. We use the ACL 3001 as the authorization information to control the traffic's access. So first, you need to enable the network connectivity, such as configure the VLAN, configure the allow pass VLAN, configure some IP address of the network. And second, because you need to configure the 802.1x packet on the SW2 here, and these two interface. So you need to configure the transparent transmission between here. Just so for these two access devices, you need to enable the layer 2 protocol to transparent transmit through it. And then you need to configure the radio server template for the radio server's IP address, for the authentication IP address, the accounting IP address, and for the cipher. And then you need to go to the 3A view to create the 3A authentication scheme, the accounting scheme, and the specific domain. And the first is the authentication scheme. You just change the mode to radius, also the accounting to the radius. And for the specific domain, the NAC, you need to bind the specific authentication scheme and accounting scheme, also the radius server template. And then you need to configure different authentications access profile. The first is the 802.1x, another is MAC address. And then you create an authentication profile, bind these two kind of access process, and also bind the specific authentication domain just for the NAC. And finally, you need to apply the authentication profile to the specific interface for the SW2, just for this two interface. And also, you need to because finally, when the terminals want to access to the the service cluster, you need to do the traffic control, right? So you need to configure the ACL first on the specific on the SW2, and then when the device access to these access devices, it will get the authorized information such as the ACL 3001, and then it will based on these ACL's rules to control this specific traffic, just like this. And finally, you need also to configure the radio servers, and for the configuration about the servers we do not mention here. And in the next slide, just for the design about the large and medium-sized campus network, we will introduce in the tomorrow's experiment of how to deploy a virtualized campus network. We will introduce how to use the campus MSNCE campus controller to do as the radio server. Okay, till now this four part is the whole information about the NAC, about the authentication. And the final part is another special technology. We call it the policy association. As usual, we will use the access layer as admission devices to receive the user's identification information and exchange this information to the radio server, right? But if in a large media-sized campus network, there are a lot of access layers devices. That means for all of the access layers, you need to configure. For all of the access devices interface, you need to configure the specific authentication configurations, right? So it's a heavy configuration for the administrators, and also for the servers. It needs to know all of the access layers, because for the servers it need to exchange the information with all of the access layer, right? So it is also a heavy workload for the servers. So sometimes we will change the authentication point upper to the aggregation layer and to the core layer. However, if we change to the aggregation layer, you need to that means for the access layer, if we change the authentication point up layer to the aggregation layer, that means if you, for example, first if you use the 802.1x authentication, you need to enable the transparent transmission for the access layer first, right? And for second, because you change the authentication point here, that means for the ACL, for the authorized ACL to control the traffic, only can be controlled on the aggregation layer. So the traffic from the same line they can just directly connect with each other based through the access layers. So in this way, you do not is not able to control the traffic. So this is the problem for you to change the authentication point up to the up layer. So in the based on this background, we just introduced the policy association. For this technology, it's just separate the authentication point as two devices. One is for the authentication access devices, another is for the authentication control devices. So you can combine these 2 points as just one point, and the one point is just the authentication point. So you change this point as separate to 2 parts, so they just do different. They just have different functions. When these two when you configure these devices as the control devices and these devices as access devices, and then they just establish a web tunnel between each other, and then they can just directly send the information through this web tunnel. So in this scenario, when a terminal send identification information to the access devices, it for the access devices, it do not process for this packet. It will directly send this information through the web tunnel to the authentication control devices. And then for the control devices, it will process this packet based on the such as, for example, for the 802.1x authentication, it will do as the EAP relay or EAP termination, and then will exchange the identification information with the radio server. And when the users pass the authentication, just successfully authenticated, it will the radio server will send the authorization information to the control devices. And for the control devices, it will directly send this authorization information to the access devices. So when the terminal's traffic enter the access devices, the access devices can do the traffic control based on the authorized VLAN and ACL. So in this scenario, the access devices can only do as receive the identification information and directly to the control devices. And for the control devices, it needs to do the function to exchange the identification between the service and itself. And then for the authorization, for the traffic control, we just send the information to the access devices. So the devices just just do the function to control the traffic. So we separate the two functions in two devices. One is the control, another is the access devices. So this is the process for how the policy association worked, and this is the whole process for it. First, it will establish first the control devices and access devices will establish the web tunnel, and then when detecting the access of a new user, just like this, the access devices will create a user association entry to record basic information such as the user and the access devices. It will create an entry first for the user and the interface. And then the control device will, and then the access devices will send the user association request to the authentication control device, a control point just for the control device. And when the control device receive it, it will also create a user association entry to save the mapping. Just save the entry the map between the user and the access devices, and then return a user association response to notify the access devices of a successful association. So till now, the association process is finished, and then the user will send the identification to the access devices to go through the authentication process. So when the access devices receive it, it will forward the authentication packet directly through the web terminal to the control devices. And then when the control devices receive it, it will just exchange the authentication information to the server. So when the authentication successfully, it will create a new user entry with the IP, user's IP, the MAC, the access devices, and the access interface and other informations. It's just create a whole entry just for the user's information with the IP, with the MAC, the access devices, and the interface. And then it will send a user authorization request to the access devices. And when the access device receive it, it will also update its association entry, and it will grant the specific network access right to the user. So when the user's traffic and get to the access devices, again it will just based on the authorization information to do the control of this traffic. So this is the whole process for the policy association. And the typical scenario of it is for the first is for the user access. For the user access, it's just for the two devices, it just use to create these entries to record the user's access. And when the users log out, the access devices will detect it immediately, and then it will go through the web terminal to tell the authentication control point that the users have logged out. You need to record it. And when the users move to another place, it can go through the association and authentication process again, and then they will create the entries again to go through the authentication process. So this is the function for the policy association. And this is different for the normally authentication and for the policy association. For the normally, the users just send the credentials for the identification information to the authentication point. And when the specific interface receives it, it will send to the authentication module, and for this module, it will exchange the information with the server, and then it will receive the authorization information. And so when traffic go to this interface, it will based on the authorization information to do the traffic control. And for the policy association, it's just separate the authentication point as 2 points. One is the authentication execution point, another is the authentication control point. For the first one, it just use the interface to receive the identification, and then it uses the interface to establish the web terminal and send the information directly through the terminal to the interface of the control point. And for the control point, it will send this to the authentication module and will exchange the authentication information to the server and to go through the authentication process. And for how to configure the policy association. First, you need to configure the authentication, and then you need to configure the access devices and the control devices. For configure the access devices, you need to select the specific interface to establish the web terminal, and then you need to configure the specific interface as the access point. And for the control devices, you need to establish the web terminal as well, and then you need to configure it as the control point. And for the control point, you need to associate with the valid access devices, right? So for the access devices, it also has the different authentication method. And in this slide, we use we did not go through the authentication process for the access devices. So we use the authentication mode as none. And then you need to create the authorization informations for the if you want to do the authorizations process on the access devices, you need to use this command to set the authorizations information to the access point. And you need to want to do the traffic control or do the reach control on the local devices or just on the control device, you can use this command. Also, an example, for this example, the SW2 is the access device, and this the SW1 is gateway, and this is the radio server. And between these two switches, we want to configure the policy association. So this is the data plane. And first, you need to configure the interconnection between the devices. So you need to create the VLANs and create the allow path VLAN, create the specific interface, and create the IP address. And then you can configure for the control for the SW1, and you configure the SW1 as a DHCP service for the users to get the IP address, because the user VLAN is VLAN 10. For the VLAN 10, you just enable the DHCP. So SW1 is the DHCP server for the users, and also it is the DHCP for the SW2 to establish the web terminal. So it uses the VLAN interface 20 as the DHCP interface server to assign the IP address for the SW2, and then it can use based on the option DHCP option 43 to establish the web terminal. And it changes the authentication mode as none. That means all of the access devices can associate with me. And then you need to do some configuration for the control mode, just for the authentication and for the authorization. So for the authentication, you need to configure the radio server template, just like the authentication configuration. And you need to configure the 3A. If you need to account the users access, you need to also create the accounting scheme, and then you need to create the specific domain and to bind with the authentication mode and the radio server. And for the specific interface, you just configure it as a control point, and for these 2 points, you just configure them as the access point. And then you need to configure the authorization configurations for the SW1. Just for the you use this command. That means you will do the traffic control by the ACL on the access devices. And this is the specific ACL. And because you need to establish the web first. So for the management traffic need to pass through directly. So you need to create a visual template to let the cab web traffic to exchange in the network. Okay, this is the whole information for the authentication. I think all of the knowledge is basic information, and in our campus scenario, we will use the controller as the radio server, and we'll use the controller to deploy the authentication automatically. Okay, next is some questions. First, when PC and dump terminals such as printers and fax machines are connected to an interface of an access devices, which authentication mode can be used? It's just like this scenario. This is the PC, this is the phone, and is switches, and is a server. So there are two kinds of terminals connected to the switches, and all of them want to meet the high security requirement. So for the PC, you need to use the 802.1x authentication, and for the phone, IP phone, you need to use the MAC address authentication, and all of them are bound with one interface of the switches. So you need to use the MAC address bypass authentication. So the answer is D. Next, based on which of the following can Huawei devices deliver user access rights to a successful authenticated user? Also, for the authorizations, we can only authorize the VLAN, the ACL, and the UCL group. And for the IP address, it cannot be authorized for the authorization. So the answer is ACD. Okay, this is all for this slide. It's just introduce three common authentication technologies. They are the 802.1.1x and MAC address and portal. And in the key point of this slide, first you need to know the basic scenario for the basic scenario for these three kinds of authentications. The second key point is the basic configuration of them. You need to know how to manually configure these three kinds of authentications, but you also need to know how to use the controller to deploy this authentication automatically. So both of this kind of authentication you need to know. Okay, so this is the whole information of this slide. Okay, do you have any question? If no, let's rest for 50 minutes, and after 50 minutes, we will introduce the next slide for the free mobility.